Hello, today I'm going to be teaching you how to factor generic trinomials. A generic trinomial is a trinomial whose coefficients are not 1. An example of a generic trinomial would be 8x squared plus 2x minus 6. As you can see, none of the variables have a coefficient of 1, opposed to y squared minus 2y minus 4. The y squared has a coefficient of 1, therefore making it a normal trinomial. When we're factoring these generic trinomials, we use a method called ax squared plus bx plus c. This is the foundation of all generic trinomials. In this method, a is the first number, or the coefficient of what we call the lead variable. X squared is the lead variable squared. B is the second number, while x is the variable that comes after it, and c is the last number with no variable after it. We use 6 rules to factor. The first rule is that we need to multiply a and c to get ac. Now that we have ac, the only thing we need for the next step is b. Speaking of the next step, this step says that we have to play the game with ac and b. Now what this game is that you have to find 2 numbers that multiply to ac, but those same 2 numbers should add to b. For example, say I had 4 as my ac and 5 as my b. The winning pair would be 4 and 1 because they multiply to 4, my AC, and at the same time they add to 5, my B. After that, the third step is that we need to use those 2 numbers that we find to split the middle term, or bx, into 2 different terms. So we're going to have ax squared plus or minus the first bx, and then plus or minus the second bx, plus or minus c. I'll get into what that means in a little bit. Now the fourth step is that we need to split the result in half. So basically we take the first half of the equation, or the first half of what is now a quadrinomial because it has 4 terms. This right here, it would be a trinomial, but since we added one more term here, we took this out but added 2 terms. Now it's a quadrinomial with 4 terms. So we split the quadrinomial in half, putting 2 terms on each side. And then we factor out the GCF for both of them. The GCF is a single term that can go into both of the terms on each side. And then you're going to put the big GCF, which is the variable plus or minus the number that you see on both sides, usually in parentheses, with either the sum or the difference of the small GCF. The small GCF is what we get in number 5. I just called it a small GCF just so there's no confusion with the big GCF. So now our first problem is 3p squared minus 2p minus 5. Now we know our first step for factoring these generic trinomials is that we need to multiply a and c. And in this case, we have 3 as our a and negative 5 as our c. So when we multiply those 2 numbers, we get negative 15. Now, our second step is that we have to play the game with a, c, and b, but in order to play the game, we still need b. So in this case, our b is negative 2. Now let's find some pairs first that multiply to negative 15. So we see we have 5 and negative 3, we have 3 and negative 5, we have 15 and negative 1, and then we have 1 and negative 15. Well, 5 and negative 3 multiply to negative 15, but they don't add to negative 2, they add to positive 2. 3 and negative 5 multiply to negative 15, and they do add to negative 2, because 3 minus 5 is negative 2. So in this case, 3 and negative 5 are a winning pair. Now, our third step is that we need to split the middle term using 3 and negative 5. So in order to make it add to negative 2p, we need to put a p behind both of the numbers, so it would look a little bit like this. We're going to have 3p squared, our original a. We're substituting negative 2p for positive 3p minus 5p. And then we're bringing down the c also for minus 5. Now our fourth step is that we need to split this quadrinomial in half. So we're going to take 3p squared plus 3p and put it on one side. And we're going to take negative 5p minus 5 and put it on the other side. So it would look like this. Now our fifth step is that we have to factor out the GCF, or as I said earlier, the term that can fit into both terms. Well, here you see we have 3p in both terms. So you put 3p on the outside, and you'll have p left over because it's 3p squared. So you'll have p left over, and 3p divided by 3p is 1. So you'll have p plus 1 in parentheses. So on this side, you'll have 3p times p plus 1. Now, on the other side, you have negative 5p minus 5. Well, you see you could take out negative 5 on both sides. So you're left with p plus 1 because negative 5 divided by negative 5 is positive 1. So you have negative 5 times p plus 1. And you can see on both sides, you have the p plus 1. That p plus 1 is our big GCF. And the 3p and the negative 5 are our small GCFs. Now our final step is that we need to put the big GCF with either the sum or difference of the small GCF. Well, in this case, we're going to put the difference of the small GCF because negative 5, well, that's negative. If it was positive 5, then it would be the sum. You'll have 3p plus 5. But now you're going to put 3p, the first small GCF, minus 5, the second small GCF. And you're going to put those in parentheses. And then you're going to multiply that by p plus 1. You ignore one of the p plus 1s. You can choose any one. It doesn't really matter. But you're only bringing one up. So our answer for this problem is 3p minus 5 times p plus 1. And if we wanted to check this, we can use a method called FOIL. So what this is that you multiply 3p times p, and you get 3p squared, which is our first term, and then you do 3p times 1, and that gets you 3p, but we need to remember that number for this next step. You do negative 5 times p, and you bring back that 3p, and you do 3p minus 5p, since it's negative 5p, and you get negative 2p. So that's this negative 2p right here. And then the last step is you multiply negative 5 times 1, and you get negative 5. So now we check this and we know it's correct. So thank you for watching. That was multiplying or factoring generic trinomials. I hope you learned something. And yeah, thank you for watching.